The National Electrical Code, which regulates electrical installations, specifically prohibits the use of cords with two male ends for backfeeding purposes. Section 445.15 of the National Electrical Code states that receptacles installed on a branch circuit shall not be connected to circuits of any other source. Using a cord with two male ends to backfeed outlets creates several electrical hazards. Firstly, overloading can occur. The generator's output may exceed the capacity of the circuit breaker or fuse protecting the outlets, leading to overheating and a fire risk. Secondly, electric shock is a hazard. The male ends of the cord can potentially come into contact with grounded surfaces, creating a dangerous shock hazard. Thirdly, circuit confusion can happen. The presence of two live terminals in a receptacle can confuse other users, increasing the risk of electrical accidents. If it is necessary to backfeed outlets, it should be done using an approved method, such as using a transfer switch. A transfer switch is a device that safely isolates the house electrical system from the utility grid and connects it to the generator. Alternatively, an interlock kit may be used. An interlock kit is a device that prevents the generator from starting if the utility grid is still active. It is not safe or code compliant to use a cord with two male ends for backfeeding outlets. Alternative methods, such as transfer switches or interlock kits, should be used to safely connect a generator to the electrical system. It's important to understand why using a double-ended male cord, sometimes referred to as a suicide cord, to backfeed a generator into a home's electrical system is incredibly dangerous and illegal. Let's delve into the specific hazards and code violations associated with this practice. Overloading is a primary concern. Residential electrical systems are designed with specific amperage ratings for circuits and main service panels. Circuit breakers or fuses are installed to protect these circuits from overcurrents, which can lead to overheating and fires. When you backfeed power from a generator through an outlet, you bypass these safety devices. The generator might be capable of supplying more power than the circuit is designed to handle. For instance, a typical household outlet is on a 15 amp or 20 amp circuit. If the generator is capable of producing 30 amps or more, it can easily overload the circuit, potentially damaging wiring and causing a fire. The circuit breaker won't trip because the power is flowing in the reverse direction, bypassing its intended protection. The electric shock is another significant risk. Standard electrical outlets are designed to have recessed female connectors for a reason. These connectors are shielded to prevent accidental contact with live electrical parts. A double-ended male cord has exposed prongs at both ends. When one end is plugged into the generator and the other is about to be plugged into the wall, or even if it's plugged into the wall and the generator is not yet running, these prongs are live and pose a significant electrocution hazard if touched. Even if the generator is not running, the prongs connected to the energized outlet are live with the potential to cause serious injury or death. Furthermore, anyone working on the electrical system, unaware of the backfeed, could come into contact with live wires, thinking the circuit is de-energized. Circuit confusion is also a major problem. Backfeeding creates a situation where standard safety assumptions are violated. Normally, when you turn off a circuit breaker, you expect the corresponding circuit to be dead. However, with backfeeding, the circuit remains energized even with the breaker off. This can create extreme confusion and danger for anyone, including qualified electricians, who might be working on the electrical system. They could inadvertently touch live wires, leading to severe electric shock. Another critical issue is the potential to energize the utility grid. When you backfeed power into your home's electrical system without properly isolating it from the utility grid, you risk sending power back onto the grid. This is extremely dangerous for utility workers who might be working on the lines assuming they are de-energized. Backfeeding can create a lethal situation for them. Modern generators are often equipped with safety features like ground fault circuit interrupters or GFCI protection. However, these features are designed to protect against faults within the generator itself or connected equipment. They do not provide adequate protection against the hazards created by backfeeding. The National Electrical Code, or NEC, is very clear about the safe and legal ways to connect a generator to a home's electrical system. The NEC, specifically Section 702.11, addresses optional standby systems and requires a transfer switch to isolate the normal power source from the alternate power source. This ensures that the generator's power cannot backfeed onto the utility grid. Let's discuss the approved methods for connecting a generator safely. Firstly, a transfer switch is the safest and most code-compliant method. A transfer switch is a device that allows you to switch between the utility power and the generator power. It completely isolates your home's electrical system from the utility grid when the generator is in use, preventing backfeeding. There are two main types of transfer switches: manual and automatic. A manual transfer switch requires you to manually switch between the utility power and the generator power. You typically need to turn off the main breaker to isolate the utility and then switch the transfer switch to the generator position. An automatic transfer switch automatically detects a power outage and switches to generator power without any manual intervention. This is a more convenient option, but also more expensive. Secondly, an interlock kit is a more affordable alternative to a transfer switch. An interlock kit is a mechanical device that prevents you from simultaneously turning on the main breaker and the generator breaker. It ensures that only one power source can be connected to your home's electrical system at any time, preventing backfeeding. Interlock kits are typically installed in the main service panel and require some electrical knowledge to install safely. It's crucial to follow the manufacturer's instructions carefully and to consult with a qualified electrician if you're not comfortable with the installation process. Both transfer switches and interlock kits provide a safe and legal way to connect a generator to your home's electrical system. They prevent backfeeding, protect utility workers, and ensure the safety of your home's electrical system. Using a double-ended male cord to backfeed a generator is never a safe or code-compliant option. The risks of overloading, electric shock, circuit confusion, and energizing the utility grid are simply too great. Always use approved methods like transfer switches or interlock kits to connect a generator safely. It's also important to consider the grounding of the generator. Generators should be properly grounded to prevent electrical shock hazards. Most portable generators have a grounding terminal that can be connected to a grounding rod. Follow the manufacturer's instructions for proper grounding procedures. If you're unsure about any aspect of connecting a generator safely, consult with a qualified electrician. They can assess your specific needs and recommend the best solution for your situation. Remember, electrical safety is paramount, and it's always better to err on the side of caution when dealing with electricity. Never take shortcuts or attempt to bypass safety devices. Your life and the lives of others may depend on it. In summary, the use of a double-ended male cord for backfeeding is a dangerous and illegal practice that should be avoided at all costs. Instead, prioritize safety by utilizing approved methods such as transfer switches or interlock kits, ensuring the well-being of yourself, your community, and utility workers. Always consult with qualified professionals for any electrical work to guarantee adherence to safety standards and regulations. Let's also look at this from a regulatory perspective. Electrical codes, like the NEC, are not just suggestions. They are legally enforceable standards designed to protect people and property from electrical hazards. Violating these codes can result in fines, penalties, and even criminal charges in some cases. More importantly, it puts lives at risk. Backfeeding with a double-ended male cord is a clear violation of the NEC and can have serious legal consequences. Insurance implications should also be considered. If your home is damaged due to a fire caused by backfeeding, your insurance company may deny your claim, leaving you responsible for all the repair costs. Insurance policies typically have clauses that exclude coverage for damage caused by illegal or negligent acts. Backfeeding falls squarely into this category. From a practical standpoint, even if you believe you're saving money by using a double-ended male cord, the potential costs far outweigh any perceived savings. The cost of a fire, an electrocution, or a denied insurance claim can be financially devastating. It's simply not worth the risk. Let's break down the approved methods in more detail. A transfer switch offers the highest level of safety and convenience. It completely isolates your home's electrical system from the utility grid, preventing any possibility of backfeeding. It also allows you to easily switch between utility power and generator power without having to worry about manually disconnecting appliances or circuits. The downside of a transfer switch is that it's more expensive to purchase and install than an interlock kit. It typically requires a professional electrician to install, adding to the overall cost. However, the added safety and convenience are often worth the investment. An interlock kit is a more affordable option that still provides a good level of safety. It prevents you from simultaneously turning on the main breaker and the generator breaker, ensuring that only one power source can be connected to your home's electrical system at any time. Interlock kits are relatively easy to install, but they do require some electrical knowledge and skill. It's crucial to follow the manufacturer's instructions carefully and to consult with a qualified electrician if you're not comfortable with the installation process. One thing to consider when choosing between a transfer switch and an interlock kit is the size of the generator you plan to use. Transfer switches are available in various sizes to accommodate different generator capacities. Interlock kits, on the other hand, are typically designed for smaller generators. If you plan to use a large generator, a transfer switch may be the only viable option. It's also important to ensure that the generator you use is properly sized for your home's electrical needs. Overloading the generator can damage it and can also create a fire hazard. Consult with a qualified electrician to determine the appropriate size generator for your home. Remember to regularly maintain your generator to ensure that it's in good working order. This includes checking the oil level, cleaning the air filter, and inspecting the spark plug. Refer to the manufacturer's instructions for specific maintenance recommendations. It's also a good idea to run the generator periodically, even when there's no power outage, to keep it in good condition. Store the generator in a safe and dry location away from flammable materials. Never operate the generator indoors or in an enclosed space, as this can lead to carbon monoxide poisoning. Carbon monoxide is a colorless, odorless gas that can be deadly. Always operate the generator outdoors in a well-ventilated area. Install carbon monoxide detectors in your home to alert you to the presence of this dangerous gas. Check the detectors regularly to ensure that they're functioning properly. Be aware of the noise that the generator produces. Generators can be quite noisy, which can be disruptive to your neighbors. Consider using a generator with a noise reduction feature or placing the generator in a location where the noise won't be as noticeable. Inform your neighbors that you plan to use a generator in case of a power outage. This will help them understand the noise and will also give them an opportunity to prepare for the outage. When refueling the generator, always turn it off and let it cool down completely before adding fuel. Gasoline is highly flammable, and refueling a hot generator can create a fire hazard. Use a funnel to avoid spilling fuel and wipe up any spills immediately. Store gasoline in a safe and approved container, away from heat sources and open flames. Keep children and pets away from the generator at all times. Generators can be dangerous, and it's important to keep them out of reach of children and pets. Teach children about the dangers of electricity and generators. Make sure they understand that they should never touch a generator or any electrical wires. Be prepared for power outages before they happen. Have a plan in place for what you will do if the power goes out. This includes having a generator, a supply of fuel, and a way to keep your home warm or cool. Assemble an emergency kit that includes flashlights, batteries, food, water, and other essential items. Familiarize yourself with the location of your circuit breaker panel and know how to turn off the main breaker. Know how to contact your local utility company in case of a power outage. Stay informed about weather conditions and be aware of the potential for power outages. Pay attention to warnings and alerts from your local authorities. Take steps to protect your home from damage during severe weather, such as trimming trees and securing loose objects. Power outages can be disruptive and inconvenient, but they don't have to be dangerous. By following these safety tips, you can protect yourself, your family, and your property from the hazards of electricity. In conclusion, remember that using a double-ended male cord to backfeed a generator is never a safe or code-compliant option. Always use approved methods like transfer switches or interlock kits to connect a generator safely. Electrical safety should always be your top priority.